final speaker in this particular session is Luke Holbrook. Luke is Chief Operating Officer at Enable My team, and just going to add a couple more minutes in here so we don't lose some time. A kind of interesting sort of shout out for Comet and Enable My team. The founder Sandeep here has been involved in Comet for almost from inception, right, from 20 years, and his business essentially was a kind of Comet was a catalyst for the creation of this business. So I think in terms of an organization, Comet's certainly had longevity. I think from my perspective, it's certainly the friendliest industry community that we have today, but it's also produced some really outstanding outcomes from many perspectives, not just from the sort of the project sharing and knowledge sharing perspectives, but it's actually been able to help organizations and small businesses like Sandeep's, achieve a dream, I think, and start their journey. So I think we're going to be talking about point clouds today, which is, again, interesting, and another type of data, I guess perhaps you consider to be unstructured data, but how do we manage that information? What do we do with point clouds, and what capabilities do they offer to us? So I'm going to try to do this right this time, because the last two intros I haven't done quite right. So you got the barcode, you can scan that and ask some questions, and we can use those in the panel session. And just another big shout out on the social media. If you want to be tweeting, tweet #Comet2024, spread the news, and let your colleagues and friends know what Comet's all about. Luke.
Okay, good morning, everyone. Yeah, thank you for the opportunity to present today. I always seem to have a habit of putting in really long titles and then struggling to read them. So effectively, we're looking at the automated comparison by utilizing the power of digital twin. So today, we're specifically going to be looking at comparing your as-built. So by as-built, I'm talking about point cloud scans compared to your design. And in this case, design, I'm referring to your 3D models. The second main takeaway is the collaborative element. So this kind of data accessibility. The term we like to be using, because obviously we're an industry where we love buzzwords, we're calling it digital twin democratization. So trying to enable people to access this data who don't have access at the moment, and to actually utilize it and understand it, I guess. So a little bit about me to start with. That's me stood in a tunnel, specifically the Crossrail tunnels back in 2016 or so. So I was a civil engineer for a number of years, actually worked for Skanska. And then I transitioned into the BIM and digital engineering team within Skanska. It was interesting listening to Jack's keynote this morning, because actually myself and Jim, who's in the audience today, we used Unity to create a digital twin of Paddington. So this was back in the day before Unity was massive in the AEC industry. So that was quite a nice throwback. I joined EMT about 6 years ago. So we really focus on utilizing cutting edge innovations. We're really staying at the forefront of technology, but most importantly, deploying that on real life projects. So we work on big infrastructure, generally rail, highways, etc. And we try and develop new tools and new technologies to solve problems which are existing. So today, going to be talking about change management. So there's a number of reasons why change happens throughout a project. It could be tracking progress throughout. It could be comparing your initial design to your end product that's being created. And effectively, change management is a big game of spot the difference. So we're going to start here with a simple room in a building. On the left-hand side, we have our 3D model. And on the right-hand side, we have a point cloud scan. So this is an operational building. So obviously, there's a lot of additional clutter in the rooms. We're not massively interested in that. But for the eagle-eyed amongst you, we'll start to notice a few discrepancies. So in the top right corner, there's an electrical unit. There's other things installed which haven't been modeled, such as the radiator on the back wall. There's also more structural elements. So this cabinet unit above the staircase hasn't been modeled. Something going on in the bottom right there. We haven't got the doors for this closet. Not too interested in what's inside it. And if you want to start getting really specific, we also need to model things like our sockets and switches. So obviously we can update the model through our comparisons, and we can start to really build up this digital twin, this model of what is on in the field. Now, obviously, that's just a very quick example. In reality, if you're performing this exercise manually, you'll be zooming in, rotating around, looking for every little discrepancy. And we've also only picked up things which are extra or missing. We're not actually checking this wall through the middle. Has it been installed in the correct place? Has it shifted, for example? Now, if you were to do this manually, obviously one room doesn't feel too bad, but what about if you had to do an entire building? Bear in mind, this building is 5 stories tall. It's got over 100 rooms. How long would that take to go through and do manually this comparison? Well, we actually know the answer because this was a real project. And it took the team about 4 months to go through and capture all of the discrepancies between the as-built and the design. In this case, there were over 230 issues, and it required numerous reworks of that model to get an accurate as-built model. So why is this important? So that example I was showing you, we're obviously comparing things like our as-built versus our design. So has the thing been constructed as it was initially intended? We've got as-built modeling. So this is actually building something from scratch where perhaps it's an older office block. You don't have the initial design, so you scan it and you model it. We want to be doing the comparison to make sure our models are accurate. Crucially, progress tracking. We've been talking about that over the last couple of days as well. If we can do this change comparisons quicker and more efficiently, we can actually do this throughout the project numerous times to make sure that we're on track. And also things like audit. When it comes to the demolition of the building, we need to do our scans. We need to understand what is in the building or the infrastructure project before we can start dismantling it. So the real focus here is trying to automate that, reduce the time it takes, reduce the manual intervention, the number of errors which are occurring. And in order to automate it, there's 5 key steps that we believe need to be addressed. So one is that data federation. It's bringing those different resources together into a single platform. Kind of ties back to what George was showing on some of those GIS interfaces where you need to have the models, you need to have all this different data overlaid. We then need to actually create the algorithms that do that comparison, playing spot the difference automatically, flagging up those differences. We can then utilize AI to really enhance this as well, and I'll go into a little bit more detail on what I mean by that, where again, we can reduce that manual input and extract additional value, which we can't do at the moment. Crucially, that number 4, linking it to your unique asset identifier. We don't want to just do a point cloud scan where we have millions of points and we say, oh, there's some extra points here. That doesn't mean anything to anyone. We need to link it back to your unique identifiers so that we can compare it to the model and so that we can create that golden thread and link it back to the rest of your asset data for the projects. And then finally, we need to actually generate a report. Even if we fully automate this process, you still need your engineering team to make those decisions. They need to have something structured and clear so that they can analyze it and move forward. So I'm going to show you a little bit of work that we've been developing. Again, this is some latest R&D that we're working on, but again, we're doing it for real projects. So we're working with the clients to understand their needs, and we're utilizing our platform Atlas. So just a quick overview in terms of what we do within Atlas. It's a GIS-based interface, and it's used for data federation. So obviously, step 1 I mentioned is to combine these different data sources together. Today, we're specifically talking about point clouds and videos. In our case, we can deal with numerous different data sets. So here is a railway project. We have things like asset data, as you can see in the 2D shapefiles. We have route data. We have forward-facing video. And these polygons at the end here are point clouds, which we'll go into more detail. And we can start to overlay these different data sets together. When it comes to point clouds and indeed models as well, these can be extremely large file types. So again, step 1 is we want to bring this into an accessible platform. So Atlas is a web-based interface, which means that we have to manage the point clouds more intelligently so that we can stream them and we can load them on any interface without the need for specialist software. We also then want to obviously bring in the other data types as well. So in this case, we've got our asset data coming from a structured asset database. We got some video feeds as well. So now we've got the data in one platform, in one tool. The next step is to actually federate those together and combine them. So we can automatically bring in multiple data sets and overlay them geolocated and coordinated. So in this case, this is a site preview surveyed by a drone in terms of the point cloud. And then we've got the models as well. So these models have come from MicroStation, but again, we work with the big vendors to make sure that we can consume both proprietary formats, but also the open types, the IFCs and the like. So that's kind of step one. We've now got it in the same platform coordinated, and we can actually begin our analysis. So if we go back to this example that we were looking at earlier that we did the manual review on. So on the left-hand side is our 3D model. In this case, this is a Revit model. And on the right-hand side is the amalgamation of many point cloud scans. So this was terrestrially scanned, every single room within the building. So you'll notice a few things straight away. For example, the roof hasn't been scanned, so you're missing the chimneys and the railings, but all of the rooms have been scanned. We've generated an algorithm now which will automatically compare these two. So we'll coordinate those, we'll run a check, and we'll instantly flag up what those differences are. So here's a really quick color coding in terms of matching elements and missing elements. Now, this is obviously configurable depending on your tolerance as well. So depending on the accuracy of your scan, you need to make it more or less acceptable tolerances. So again, you can very quickly see, say the roof is missing, for example. Now, obviously, this is going to flag it up to your engineering teams. It's still your engineering teams to say, no, it's not an issue. We didn't forget to build the roof. It's just not in the scope of works. But this obviously becomes a lot more powerful when we then drill down into the individual rooms. So again, very high level in terms of what is matching, what is missing. There's some things here that you would expect to be missing. The windows, for example, have come out red. Generally, you're not going to pick up glass in a laser scan. So again, it's going to flag as an issue, and your teams will simply say, not to worry. But then it'll flag other things. Say, example, the entire wall on the right-hand side. It could be that that wall hasn't been installed yet if it's during a construction project. It could be that it has been installed, but it's out of tolerance. And again, this instantly highlights to your teams what to look at. We can then take it to the next level is when we start to then overlay the extra items. So during a construction project, you'll have a lot of extra stuff in a point cloud scan. Some of this will be temporary work, so you're not particularly worried about that. You can toggle it off. But some of it will be additional items which have been installed and for whatever reason weren't modeled. Things like your electrical boxes and that cabinet above the stairs, for example. But again, as I mentioned earlier, we don't want it just to be generic points. We need to actually provide some context here. So we ran the algorithm within Atlas. Everything we do, we believe in the interoperability story. We want to push everything open and have open standards. So here, for example, we've output our processing, and we've just opened it in an open source software cloud compare. This could be viewed within our platform. It could be imported into a third-party tool. So what you'll see here is, again, it's the basic color coding. But when you click on in the individual elements, they've actually automatically been clustered. So here they've been clustered as per the model elements. So you'll see your GUIDs on the left-hand side, or your unique asset identifiers. And again, you can just toggle these off for clarity. You'll see some things. So inside here, we've got this extra internal wall, which hasn't been modeled. And again, we cluster those together. So instead of just having 30,000 random points, we've clustered those into a single asset, which then can be commented on, collaborated, and carried through the project lifecycle. And same for the assets which have been detected as matching or missing. Again, they're clustered together. You've got that unique identifier. And this then allows us to start to generate those reports. In terms of the report, so everything that we generate is through just an open JSON format. That then allows us to generate custom reports per customer, or it allows our clients to generate their own reports as well based on the data that they find interesting. The platform itself, again, being web-based, means you can actually interrogate the data directly within the tool. So you can zoom to different cameras angles, you can send links to people, and they'll be able to dive straight into the model. You don't need to worry about downloading files and all of that stuff. You can leave comments and feedback. And again, that report can be generated and exported into BCF format. So again, industry standard if you want to open it or continue your interrogation in another tool. So I mentioned using AI at the start of this talk as well. So we do a lot of automated feature extraction. So we can build up these number of algorithms to recognize different asset classes. So obviously, the example I've given previously was in a building. On the right-hand side, we're within a rail environment. We've trained our models on a number of different asset classes. So here you can see the railheads, the vegetation, platforms, signals, overhead lines, etc. All of that can be classified. And what that means for this comparison part is when we're detecting those extra asset classes, we're no longer just saying, here's some extra points. We can actually say, here's an extra pipe of diameter 100 millimeters and length 3.5 meters at this location. So suddenly you're already doing a lot of that manual work. You're creating those assets. You could even then take it one step further and start to do some parametric modeling. So when you recognize the asset in the field, it will automatically drop in a 3D model of the correct dimensions of the correct asset type, linking back to kind of this, I guess, the modularization, having those object libraries as well as you build those up. Again, it works for things like MEP. Ideally, in the future, that will also work structurally as well. So to conclude, so going back to this project that I started on, the one that took about 4 months to process manually, we ran it through our algorithm and it took just over 3 hours to process. So in terms of the time saving, it's just not comparable from 4 months to 3 hours. Now, obviously, as with anything which is utilizing automation and AI, your output isn't 100%. You're still going to have your engineering teams to then review that. You're going to have things which aren't actual issues, and you can, again, tick those off. But it gives your teams a massive head start in terms of what are the areas of interest, what should they be looking at. And more importantly, it allows for repeatability. If something takes 4 months to do, you're not going to do it that often. If something takes 4 hours, you can run that as frequently as you like. As the technologies are developing, our hardware, our data capture tools, they're getting way more advanced. It means that you can do a survey once a week if you want to. And now that the automation of the processing is also in place, you can then run that every week and you have that progress tracking throughout. Obviously, it's a lot more cost effective and scalable. So these manual issues, if you're going through that building with 150 rooms, you're going to miss things. You're going to make mistakes doing it manually. And again, this will help draw the attention to those key areas of focus. And then it's the integration part. So again, the topics over the last couple of days have really been focusing on that. We like to integrate with as many different tools as possible. So we'll connect directly in with the model repos, whether it's ProjectWise or another common data environment. We'll pull that down automatically. That can be marked as a flag ready for comparison review. That will be brought into the system. Algorithm will be run automatically and exported back into the system of your choice. So again, integration is key here. One software is not going to solve every problem. And that's me. Look forward to your questions on the panel.
Brilliant, Luke. Thank you very much. So we're ahead of time once again. We've got 15 minutes to fill. So if anybody wants to come up and just entertain us or sing a song or, I don't know, do something, we can do that. But I guess for the moment, we can just have a just start the panel, yeah? Yeah, fantastic. Okay, brilliant. I know we've got a lot of questions that came in, so thank you for everybody that contributed. Sorry, did you have a? Oh, right. Okay, yeah. Let me just. We'll pass the mic to you. If you're happy with that. Yeah, sure. We'll get the panel people up, and then we'll go from there. So if the speakers can come up and join us, I think we've got another live mic here.